And I'd like to say a few more words about our complexes. For each of our complexes that we draw this semester, we have to keep track of formal charge about each atom in every complex that we draw. We want to go beyond just placing a charge on the outside of the bracket to designate charge of our complex. So there is a formalism, a method for tracking charges in complexes. Since formal charge is a formalism, I will give you my formula for calculating formal charge. Formal charge, Fc, equals atom group number from the periodic table minus the touch. That formula can be rewritten in the following manner. Formal charge equals group number minus dots and dashes. Let's see how we might apply this to calculating formal charges over each of the atoms in these substances that are drawn on the board. For example, oxygen is in group 6. Formal charge of oxygen in water is group number 6 minus dots and dashes. There are 2 dashes and 4 dots for a total of 6. 6 minus 6 is equal to 0. If we wanted to look at the formal charge of carbon and carbon dioxide, carbon is in group 4. Formal charge of carbon is equal to group 4 minus 4 dashes. 4 minus 4 is equal to 0. If we wanted to calculate the formal charge on this oxygen and carbon dioxide, formal charge of oxygen and carbon dioxide would be group number minus the touch. And we can just use our finger now and count. 1, 2, 3, 4, 5, 6. 6 minus 6 is equal to 0. If we wanted to calculate the formal charge of hydrogen, hydrogen's in group 1. 1 minus 1 touch is equal to 0. So formal charge can be easily calculated. Let's see what the formal charges are on the atoms in our complexes that we've drawn. Let's begin with this oxygen. This oxygen is in group 6, and there are 1, 2, 3, 4, 5, 6, 7 touches. 6 minus 7 is equal to -1. Thus, the formal charge in this oxygen is a -1. If we wanted to calculate the formal charge on this oxygen, formal charge of this oxygen, again, is group number 6 minus 1, 2, 3, 4, 5. 6 minus 5 is equal to +1. So the formal charge on this oxygen is +1. For the other atoms, we've already calculated similar formal charges. Group number of carbon is 4. 4 minus 1, 2, 3, 4 touches is equal to 0. Oxygen is in group 6. Minus 1, 2, 3, 4, 5, 6. 6 minus 6 is equal to 0. If we were overall reaction, we said water had no charge, carbon dioxide had no charge, our final complex had an overall charge of 0. We can see that the overall charge is 0 because these two formal charges add up to 0. Let's calculate the formal charge on this oxygen in this complex that we had drawn earlier. The group number of oxygen is 6. 6 minus 1, 2, 3, 4, 5 is equal to a positive. Thus, this oxygen bears a positive formal charge. Likewise, our overall complex bears a positive formal charge because this oxygen's formal charge is positive. Let's see if we can calculate the formal charge of oxygen and hydroxide ion. Oxygen is in group 6. 6 minus 1, 2, 3, 4, 5, 6, and then there's a bond here for 7. 6 minus 7 is a -1. The charge of oxygen and hydroxide ion is a negative formal charge.